Welcome back to the deep dive. Today, we are putting on our logistics goggles, and trust me, you're going to need them.
Oh, absolutely.
The document in front of us is a really deep quantitative look at the actual cost of fighting a modern war. We're talking hardware, bandwidth, complexity, all of it.
Yep.
It's a white paper called Force Generation and Logistics Calculus, and it's essentially, well, it's the technical blueprint for equipping a next-gen motorized division for what they call LSCO, or large-scale combat operations.
That's a perfect way to put it. This isn't, abstract theory. This is the pure hard math.
Yeah.
It's the math you need to validate some of the military's most, let's say, aggressive modernization concepts. We hear these buzzwords all the time.
Oh, yeah. Containerized fires, edge compute.
Exactly. And those ideas, they're fantastic on a PowerPoint slide, but they're useless if they can't function under the immense consumption rates of a real peer conflict.
So this paper tries to bridge that gap.
It addresses it head on. It provides the mathematical methodology to make sure that, when the shooting starts, the division actually has what it needs. That complex blend of robots, sensors, and just the sheer volume of munitions required to win.
Okay, let's unpack this with the scale right away, because the core calculation that drives all 47,000 items in this inventory, it's based on a very specific, very high-intensity scenario.
It is. The entire discussion is anchored on this single operational calculus. The scenario is crystal clear. One of our friendly motorized divisions goes up against one enemy armored division.
And the goal isn't just to survive.
No, the goal is military parity, which really means achieving destruction dominance over the other guy.
And that goal is defined mathematically, which I think is the crucial starting point for this whole logistics nightmare.
Precisely. The target set is massive. You're looking at 3,000 enemy vehicles.
So that's everything. Tanks,
Basically,
IFVs.
Everything. Tanks, infantry fighting vehicles, heavy artillery, and maybe most importantly, their critical command and control nodes, their C2.
And to win, we have to achieve a 70% destruction rate.
A 70% rate. So do the math. That's 2,100 high-value targets that have to be eliminated. Guaranteed.
2,100 targets. Okay. But here's the kicker, the assumption that just immediately inflates the whole logistics burden. The paper does not assume it's one shot, one kill.
Not at all. I mean, that would be completely unrealistic in modern combat, wouldn't it? You have countermeasures, electronic warfare, jamming, just simple physics causing things to miss.
Sure.
So they apply this critical efficiency factor. 3 strikes are required for every 1 successful target elimination.
Wow, 3 to 1.
3 to 1. It accounts for misses, for enemy intercepts, for degraded systems under the stress of combat. So you take your 2,100 required kills, you multiply by 3, and boom.
6,300.
The division must be capable of generating a staggering 6,300 successful strikes. That number right there is the demand signal for every rocket, missile, and smart munition we're about to talk about.
6,300 successful strikes. Just to win this one initial battle. But the planners, they take it one huge step further with what they call the total loadout multiplier. This is where the whole Iron Mountain idea really starts to take shape.
This is a key doctrinal shift. They apply a 1.3x multiplier.
A 30% reserve.
A 30% reserve requirement on top of that base calculation of 6,300 strikes and all the systems that go with them. Now, why do they do that?
For the fight after the fight.
Exactly. The paper calls it the fight after the fight. They are not just stocking up to win the current defensive battle. They are calculating what they need to immediately transition to offensive operations, or just to sustain the pressure for longer. You have to maintain momentum.
You can't stop to rearm.
You can't. And that simple 30% reserve establishes this absolutely massive initial inventory, and it shifts the focus from just, surviving the present to ensuring you can dominate the near future.
That planning assumption is huge. It basically means the whole logistical system is designed for continuous, high-intensity combat, not just a quick clash.
Right. It demands speed and volume from the get-go.
Okay. Let's move straight into Section 1 then and talk about how this force is actually structured, because this motorized division, it's less about traditional heavy armor and much more about distributed compute power, isn't it?
It's entirely built around data processing and dispersed strike capability and distributed sustainment. The organizational structure is defined by this. Well, it's a very clean, yet highly complex 13927 model.
A fractal combat organization.
That's a great term for it.
So let's break that down top to bottom.
Okay, at the highest echelon, you have the 1 division. and it functions as the strategic data hub. This is the ultimate nerve center. It's collecting massive data sets, it's running strategic AI models, and it's translating that strategic intent down the chain.
Making sure everyone is pointed at that 70% goal.
Precisely. Below that, you have the 3 brigades. These are designated as the containerized fires hubs.
So they're the shooters.
They're the big shooters, yeah. Their role is to manage the deep fight. They house the long-range bulk strike capacity. And they often use commercial ISO containers as, missile launchers and storage. They're less maneuver elements and more like giant mobile supply and fire support platforms.
So the brigade provides the mass, the long-range firepower,
Yeah.
but the actual data crunching and the ground fight happens at the lower echelons.
Exactly. The 9 battalions are the crucial middle managers. They are the compute and sustainment hubs.
So they're the brains of the local operation.
They really are. They take the strategic data from division, they fuse it with this intense flood of local sensor data coming in from their companies, and they manage the immediate logistics flow. They are the local fire control centers.
And at the very tip of the spear.
You have the 27 companies. These are 150 personnel sense-infect maneuver units. They're the smallest unit with its own organic strike and recon capability. They are the fighting edge. Their job is to find and kill targets in their sector using munitions that are right there with them.
That structure, where the battalion is a compute hub, not just a tactical HQ. That's key. But, like we said, the most crucial insight in this whole white paper is this philosophical shift in how they categorize equipment. They're moving away from just platform names to an acceptance of loss.
This is fundamental. This classification system, survivable, attritable, and consumable, it dictates everything. Acquisition budgets, supply chain priority, you name it. It's all about pre-calculating the risk.
Okay, so let's start with the stuff you absolutely cannot afford to lose, the things that keep the lights on and the brain working.
Those are the survivable assets. They make up about 22.30% of the total loadout. This is your critical infrastructure, your main C2 networks, the big SAT comm terminals, and your human crewed systems.
So if you lose one of these...
If you lose a survivable asset, the paper is clear. It's a critical failure for the entire operation. These are the systems that allow the distributed brain to command all 47,000 other systems.
Okay. Then we get into this gray area, things that are sort of disposable but not really.
That's the attritable class. It's about 20.8% of the total volume. These are what you'd call commodity platforms, mostly robotic, reusable systems like certain UGVs or persistent drone platforms.
And the key distinction here is what?
The crucial distinction is that losing one is strictly a financial calculation. It's not necessarily a tactical failure. If an attritable drone draws $1 million enemy missile strike, or it confirms a position of an artillery battery before it gets shot down.
That's a win.
That's a successful trade-off. Planners budget for these losses. They still want to recover and reuse them if they can, but their destruction is part of the plan.
So attritable assets buy you time and information, which lets the survivable systems keep making smart decisions. And then finally, the biggest category, the one that really defines this whole logistics challenge.
The consumable class. This is the largest category by a huge margin. It's an astounding 56.90% of the total loadout.
Over half of everything.
Over half. And these items are designed to be destroyed when you use them. We're talking all the munitions, the vast number of passive sensors, single-use payloads. They are the operational equivalent of printer ink cartridges. You buy them knowing they're going to disappear in the process of getting the job done.
Over half the logistics chain is designed for immediate destruction. I mean, if you compare that to a World War II armored division, where pretty much every tank or truck was a high-value protected asset, this is a radical inversion of priorities.
It confirms that modern warfare, especially against a peer, is fundamentally a war of attrition built on volume, on strike capacity. And when you pull back to the grand total, just to execute this one engagement, the logistics chain has to deliver over 31,000 discrete systems and munitions.
And that's before the reserve. Once you apply that 1.3x multiplier, the total logistical demand for this one division-level fight explodes to 47,408 items.
That number, that is the Iron Mountain this paper is trying to figure out how to manage.
That's the scale. So now we have to look at how these 47,000 items actually talk to each other. Let's move into section 2, the digital nervous system. This is the network foundation that must survive, right?
Absolutely. Because if the C2 fails, the whole system just collapses into 27 isolated companies holding 6,300 munitions they can't coordinate.
Coherence is everything. The paper really emphasizes network density and this requirement for transport-agnostic mesh networking. What does that mean exactly?
So this is the backbone of the system, a high-density self-healing network. The reason it needs to be transport agnostic is crucial. It means the network doesn't care how it sends data.
Okay.
It can route it over radio, fiber, satellite, whatever connection is available. This ensures that machine-to-machine C2 isn't reliant on any single pathway. The systems just talk seamlessly. Robots to sensors, sensors to servers, servers to launchers.
And the sheer number is what's staggering here.
It is. 7,150 active nodes are required in the total loadout, just to connect the 4,000-plus soldiers, their vehicles, and the thousands of robotic systems.
7,000 nodes in one division's area. That's not just connectivity. That sounds like complete saturation of the battle space with digital communication points, just for redundancy.
Total saturation.
Yeah.
And those local mesh networks, they have to connect the tactical fight back to the strategic level. That's where the high echelon connectivity comes in.
The big pipes.
The big pipes. The battalion compute hubs, which, as we said, are basically clusters of blade servers in a box, they need to link up to higher command. That means they need 59 next-gen, high-capacity SATCOM terminals.
And these are survivable systems.
Absolutely critical survivable systems. They provide that fire hose connection you need to pull strategic data in and push combat telemetry out.
So the battalion is the first point of heavy data processing, the edge compute location. This requires a dedicated, high-bandwidth local network. You can't just piggyback on local cell towers.
No, exactly. This requires militarized private network solutions. The paper calls for 24 private 5G systems in total, including spares, mostly for the battalion level.
Why 5G?
Because traditional military radio bandwidth just can't handle it. It can't handle the real-time, high-volume sensor data that's flooding in from thousands of autonomous systems at the same time. For real-time targeting, the latency has to be near zero.
But the true nerve center isn't the data pipes themselves. It's what's processing all that data. And now we're talking about AI and predictive command.
Right. The paper defines the predictive C2 platform as a survivable requirement. It demands 47 AI compute nodes.
And their job is to run micro orders.
That's the term, yeah. Instead of waiting for a human to look at a screen and approve every single fire mission, the AI is constantly calculating and issuing these small, automated tasks to the robotic assets. Move here, observe this, prepare to strike, all based on the division's overall intent.
And the most fascinating requirement here, which you touched on, is this idea of constitutional AI compliance.
This is a critical legal and operational burden. It's huge. The AI must ensure that those micro-orders strictly adhere to policy, to targeting laws, to the rules of engagement without a human looking over its shoulder every second.
Wow.
It forces software developers to build in constraints that guarantee ethical and legal compliance at machine speed. It's trying to solve that immense speed gap between human decision-making and machine-driven combat. The AI has to be legally verifiable, not just fast.
That one requirement alone completely changes how you develop military software. But what happens when, not if, but when, this whole digital nervous system, the 7,000 nodes, the 5G, the AI, gets jammed or contested? What's the analog fallback?
That's the absolute necessity of redundancy. It forces you back to robust, simpler systems. The paper requires a total loadout of 1,300 next-gen combat net radios.
Just regular old radios.
Basically, they're simple voice communication radios, but they serve as the indispensable voice redundancy for key leaders when that sophisticated data mesh is completely shut down by enemy electronic warfare. The survivable network has to include these low-tech, hard-to-kill alternatives.
It's a beautifully complex system designed to maintain coherence under impossible conditions. Okay, so we've got the digital brain connected. Let's move to section 3. Sensing, screening, and spectrum warfare. We still have to find those 3,000 enemy targets. And this is where we start trading those disposable assets for knowledge.
This section shifts us heavily into that consumable class. To maintain custody of 3,000 targets spread across a huge area, you have to just saturate the battle space with cheap disposable eyes.
Starting on the ground, with the automated passive and active land sensors, the volume here is it's just overwhelming.
It is. The calculation demands 7,020 units in the total loadout.
7,000.
7,000. It makes them one of the most numerous consumable items in the whole inventory. These are cheap, low-power, expendable sensors you use to sense out ahead of your forward line of troops, the FLOT.
So you just scatter them everywhere.
You scatter them, they get placed by automated systems, by soldiers, and you just accept that they're going to get destroyed either by accident or by enemy action. This high volume allows the companies to constantly refresh their immediate tactical picture without sending soldiers into dangerous forward scouting positions.
And then moving to the air, For that persistent overhead view, we're back in the attritable class again. The operational, attritable, persistent airborne sensors.
Here, the requirement is for 1,300 flights or hulls. These are tactical, reusable UAS. You can think of them as high quality but ultimately disposable camera drones.
Right.
They're constantly streaming intelligence data back to that battalion fusion engine. And because they're attritable, the plan dictates a high loss rate. You need this huge inventory just to maintain 247 coverage, constantly rotating drones in and out of contested airspace.
Now let's talk about using robotics not just for finding things, but for shaping the battlefield, using platforms to actually herd the enemy.
The uncrewed automated modular ground platforms, or UGVs, are central to this. You need a total loadout of 351 vehicles.
And these are attritable.
They are, and their primary role isn't really reconnaissance, it's screening and drawing fire.
They're bait.
They are absolutely bait. You place them forward of your human formations to force the enemy to reveal their positions and, ideally, waste expensive munitions on a cheap commodity platform. They're reusable, but, their tactical success is often measured by how many times they survive getting shot at.
And that physical screening, that bait, is reinforced by active countermobility measures. Things designed to funnel those 3,000 enemy targets into specific kill zones.
Yes. You channel the enemy force using 351 autonomous minefield system deployments. This is a pure consumable asset. These systems can rapidly deploy smart minefields, forcing that enemy armored division to maneuver exactly where you want them. It makes that 6,300 strike requirement much, much more efficient. It's force multiplication through terrain denial.
Okay, so the final critical layer of this section is the invisible fight, electromagnetic warfare, or EW, and deception. How do you protect your own 7,000 mesh nodes while you're trying to blind the enemy's command structure?
You manage this through careful resource allocation. For protection, you need 12 operational electromagnetic attack and protection systems.
And these are survivable.
These are high-value, survivable assets. They are powerful systems designed to jam or disrupt enemy communications from a protected gray zone. You have to protect these because they are what keeps your own C2 network functioning.
And then on the other side, for active deception.
For deception, we go back to the attritable category. We use 351 multi-echelon Mal-deck emitters.
So decoys.
Exactly. They're decoy systems designed to mimic a command post, or a high-value vehicle's electronic signature, or a logistics hub. The concept is machine-to-machine Mil-deck, using cheap electronic emitters to flood the enemy's targeting systems with false information.
Forcing them to waste their expensive missiles on a $500 box.
That's the idea. It's a cost-benefit calculation on an electronic scale.
The whole system is designed to trade cheap data, cheap deception, and cheap protection for the successful targeting of the enemy. Okay, so we've found our targets. Section 4 is the final step, delivering the 6,300 required strikes. This is all about air autonomy and all-domain fires. This is the massive consumption engine.
This is the Iron Mountain in action. This section defines the logistics of mass destruction. It explicitly follows that ink cartridge model we talked about where replacement and expenditure are just assumed. It's not something to be avoided.
Let's break down the air-based strikes by range and purpose, starting with the immediate close-fight punch for those 27 maneuver companies, so 0 to 15 kilometers out.
That is the domain of the intermediate range, rotary wing UAS munition. The loadout requires 4,550 units.
4,500.
Just of this one type. These are attritable assets. Sometimes they strike a target. Sometimes they just provide close-in reconnaissance. They are the primary organic strike mechanism for the company level. It's the immediate response when a sensor picks something up. The high volume ensures every company has continuous fire availability.
Okay, so now moving out to the deep fight, 15 kilometers and beyond. How do we get that volume and persistence deep inside enemy lines?
That's done through the brigade's containerized capacity. We have 3,250 long-range, high-altitude loitering UAS munitions.
And these are consumable.
Pure consumable. These represent the core volume of fire for the deep fight. They are essentially programmable smart missiles that can just orbit an enemy target area for hours, waiting for the command from the battalion hub to strike. They provide a persistence that traditional artillery just can't match.
And for the most important, fixed enemy targets, the high-value ones like their radars or command bunkers or air defense systems, I assume we're reserving something more precise for them.
Precision comes from the long-range, low-cost cruise missile. 780 missiles are required for the loadout, and these are housed in those standard ISO shipping containers, which reinforces that whole containerized fires concept.
The ability to just drop a shipping container anywhere and it becomes a missile launcher.
Exactly. It lets you rapidly deploy bulk precision weapons using logistics that mimic commercial freight standards. You get massive distributed strike capability without needing traditional bespoke launchers.
This brings us to the core bulk logistics, the really massive volume items that are moved and fired in a more traditional sense, but are still integrated into the digital network.
You just need massive volume. That means 3,900 containerized missiles and rockets, pure consumable bulk fires. These are also moved using commercial freight standards, maximizing the speed and quantity of weapons you can get to the fight. But while these are essential, they are not the cheapest way to hit that volume target goal.
The absolute cheapest way to generate those 6,300 strikes has to rely on the simplest munitions, right?
It has to. The requirement calls for a staggering 6,500 cost-effective offensive and defensive munitions. This covers your basics. 105 millimeter, 120 millimeter cannon shells, mortar rounds. These are the volume target killers.
The dumb rounds.
Pretty much. But when you are fighting for destruction parity against 3,000 vehicles, the simplest rounds, when guided by this incredibly sophisticated sensor network, provide the most cost-effective way to achieve the highest concentration of fire.
I noticed the paper details a specialized capability under the fires section, something called the wolf pack concept.
Yeah, this refers to the 1,755 operational, attritable, reusable, penetrate, and defeat teaming systems.
Okay, what is that in plain English?
These are specialized coordinated drone swarms, often called wolf packs. They're synchronized by the battalion compute hub, and their job is highly dangerous. Suppression, penetration, blinding enemy sensors right before a main strike is delivered by a more expensive missile. They're classified as attritable because, well, while they're technically reusable, their aggressive mission profile guarantees are going to make significant losses. They're the sacrificial edge of the kinetic fight.
We've established this enormous consumption rate, the sheer volume of material needed to deliver 6,300 strikes. But none of this works if the supply line just collapses under its own weight. So let's jump to Section 5, Agile Sustainment and Automated Life Support. This is where the logistical challenge, the Iron Mountain, has to be solved by moving to an autonomous kind of Amazon Prime model.
The paper is unequivocal on this. Traditional linear supply lines that rely on people manually handling things are a single point of failure. They're a non-starter for this kind of operation.
So to manage the ink cartridge life cycle of 47,000 items.
You have to automate logistics, you have to assume immediate need, and you have to accelerate replacement.
And the most radical solution to reduce the strain on that supply line is manufacturing at the point of need. You don't have to haul certain replacement parts if you could just print them locally.
It's a revolutionary logistical shift. And it's supported by survivable assets. We need 36 hybrid additive subtractive manufacturing systems deployed right down to the company support level.
So 3D printers in the field.
Very sophisticated ones. They can both 3D print plastic and metal parts, that's the additive part, and machine high tolerance components, which is subtractive. They can do it right where they're needed. This provides immediate spares for drones, sensors, vehicles. It drastically increases your resilience.
And for the munitions themselves, they have a way to reduce the weight and volume of the non-metallic parts.
Yes, with the containerized blow molding systems, they need 12 systems at the battalion level. These manufacture things like plastic casings, fuses, and packaging right there on site.
So you're not shipping air.
You're not shipping air or bulky plastic. You ship the base materials, not the big finished casings. It drastically reduces the volume and weight of what needs to be hauled into the fight.
Okay, now for the actual transportation of stuff, you can't manufacture fuel, food, bulk munitions. This is entirely reliant on autonomous, attritable assets.
Precisely. For ground movement, the goal is to remove humans from the deadliest part of the supply chain. So you have 211 uncrewed ground payload transportation vehicles. These are autonomous leader-follower convoys.
So if a convoy carrying ammunition gets hit,
it's a calculated financial loss. It's not a human casualty event.
And for emergency, high-value, time-sensitive items that just can't wait for a ground convoy to get through.
That's handled by the air. The paper requires 117 uncrewed aerial payload transportation drones. These are heavy lift drones managed at the battalion level for immediate emergency resupply of critical items.
Like blood plasma or batteries.
Exactly. Blood, high-capacity batteries for the C2 nodes, specialized payloads. They can often bypass difficult terrain or ground obstacles entirely.
The capstone of this whole autonomous logistics network seems to be the autonomous forward arming and refueling point sites, the FARPs, the future gas station and warehouse for the robot army.
That's a perfect description. The fully automated sustainment hub. 47 autonomous ARF sites are required, and these are survivable systems. This is key infrastructure where drones can recharge, refuel, and reload payloads without any human interaction.
So even the logistics facilities are becoming autonomous.
They have to. They are the linchpin of the continuous fight, so they become high-value systems that must be protected.
Finally, we have to look at how medical care is integrated into this autonomous network. Life support becomes a C2 problem too.
It does. Medical triage now relies on predictive AI. We need 702 AI-assisted triage and treatment kits.
And what are those?
There's sophisticated wearable monitors on every single soldier, constantly feeding vital sign data back to the battalion compute hub. This is survivable infrastructure that allows the AI to predict medical supply needs and trigger push-based logistics for medical resources before a medic even requests them.
And I assume you're leveraging that same automated transport network for evacuating casualties.
Of course. The paper plans for 71 uncrewed automated mid-evac systems. These use the existing autonomous logistics vehicles, either repurposed or dedicated, for backhaul evacuation. Again, the primary goal is removing human risk from moving casualties in the immediate area of operations.
But even with all that automation, some consumables are just irreplaceable, like life-saving medical supplies.
You still need volume for those critical, non-transportable items. That means 1,755 units of freeze-dried plasma are pre-positioned down at the company level.
Right where you'll need it.
Right where you'll need it. This critical consumable life support item is distributed low enough in the chain to be immediately accessible while those autonomous evacuation systems are on their way. It's all about maximizing the window of survivability.
That paints an incredibly holistic picture of a logistics system that is super high-tech and distributed, but fundamentally it's designed to manage just massive, massive volume consumption.
That's the core of it.
So let's move to our final analytical section, Section 6, the total logistical roll-up and echelon responsibilities. We need to review this demand signal by echelon to really understand who is consuming what and who's managing the whole process.
This is where we bring all 51 capabilities and their specific quantities into sharp focus based on that 13927 structure. And the profile of each echelon is drastically different. It really reflects their primary mission.
So starting at the bottom, the company level, the sense and effect echelon. They are the immediate consumers, the cutting edge of the fight.
The company level is where the fight is felt instantly. Their attritable load, which includes those UGVs and aerial platforms for immediate sensing, is high. It's about 5,700 items.
Okay.
But the overwhelming volume, the real story, is in their consumable load. Approximately 23,000 items.
The 23,000. That's almost half of the entire divisional loadout right there.
It is. It's sensors, it's immediate strike munitions, anti-mobility systems. They are the primary consumers of all the disposable items, and they're focused on generating immediate strikes to hit their local piece of that 70% destruction goal.
Okay, moving up to the battalion level, the compute and sustainment echelon. Their profile is much more focused on management and information processing.
The battalion is the brain and the logistical flow manager. Their survivable load is small by volume, only about 150 items. But these are the most critical things: the clusters of blade servers, the 5G systems, the S8 terminals, the medical cells.
So they manage the flow.
They manage the flow of data and supplies. Their attritable load is around 2,500 items, and that's mainly the specialized assets they use to support the companies, like the swarm drones, deception decoys, and those aerial resupply platforms. They're the nervous system connecting consumption to the strategic direction.
And finally, the brigade, the containerized fires hub. They're just holding the long-range magazine for the division.
Their inventory is focused entirely on mass strike capacity. Their survivable load is minuscule, maybe 20 items, just high-level C2 and EW systems. Their attritable load is also small, around 400 items, robotics for handling containers, some specialized launchers.
But their consumable load.
That's where it's at for them, a consumable load of approximately 8,500 items. And that is almost exclusively the long-range missiles, rockets, and loitering munitions stored in those commercial containers. They are the strategic magazine that's used to apply massive coordinated pressure.
This breakdown just clarifies the whole strategic design, doesn't it? The company burns the volume, the battalion coordinates the burn, and the brigade provides the deep strike capacity to suppress enemy reserves.
Exactly.
But the ultimate aha moment comes when we go back to those core classification percentages, when we combine all 47,408 items across all echelons into one total statistical view.
This is the critical statistical takeaway. This is the thing that has to inform all future acquisition and planning. It really defines the entire ethos of this modernized division.
So let's review those percentages one last time, just to drive home this point of planned consumption.
Okay. The total loadout required for this singular division-level engagement is 47,408 items of that total volume.
The survivable items, the irreplaceable C2 backbone, the manufacturing systems, the things that protect the humans.
They account for only 10,591 systems, or 22.30% of the total. They are the absolute minimal infrastructure needed to run the system.
Then the attritable items, the commodity robots designed to draw fire and screen.
They account for 9,868 systems, or 20.8%. They are the calculated trade-off.
Which leaves
The overwhelming volume. Consumable items, munitions, payloads, sensors, they account for 26,949 items, or an incredible 56.90% of the entire logistics volume.
56.9%. It means that the success of the modern motorized division is measured not by how well it protects its expensive assets, but by the efficiency with which it just burns through its vast, pre-stocked inventory of disposable ones.
That's it. The financial calculation for the cost of this engagement is enormous, but the math dictates that the consumption rate has to be maintained to win. It fundamentally changes the relationship between your equipment and your mission success.
The entire force is basically just a highly automated platform designed to deliver and support this calculated massive consumption.
All in pursuit of that 70% destruction goal. We've gone from worrying about losing a few tanks to explicitly planning to use up over half of our initial deployment package.
This analysis perfectly synthesizes what we've been talking about. The future motorized division is.
Yeah.
It's less a collection of human crewed platforms that you must protect at all costs, and more a dense, disposable, highly automated network that's just designed for continuous consumption.
Yeah.
We are building the Iron Mountain so that we can immediately spend it all in a single surge of overwhelming distributed force.
It shifts the goal of logistics from simply minimizing waste to precisely optimizing calculated massive expenditure to achieve the desired effect. And it raises a really important question for you, the listener, and for military planners globally.
Go on.
If knowledge is most valuable when it's understood and applied, what does it mean for military planners and supply chains to intentionally designate nearly 60% of an operational unit's equipment as disposable before the fight even begins?
Does this shift the definition of loss from a strategic failure to just a routine cost of operation? And what does it mean for the speed required by the defense industrial base to replenish that 56.9% before the next fight begins?
You have to consider the strategic implications of building an Iron Mountain that is designed to be consumed entirely in a single decisive engagement. That is the true challenge of logistics calculus in modern warfare.
A lot to think about as you contemplate the future of force generation in the supply chain. Thank you for joining us on this deep dive into the logistics calculus of modern warfare.
Always a pleasure.